Alright YouTube, hello. Thank you for your interest in my channel. At some point in the video I said that there might not be another high voltage generator ever happen in my lifetime. This is the second prototype that I did in 92 or so. But some things have changed that may kind of eradicate that thinking. The big problem with this high voltage generator has always been the same thing. You have no idea how much voltage is coming out of this thing. That's kind of a real pain in the ass. Somebody says, well, how much voltage is coming out of the top of that thing? I always have to look at them and say, well, 6 to 1, half a dozen to the other. Take a wild guess. I knew that when I built this in 92. But considering that my first model had a lethal oil leak, there was no way that I was putting any more holes in this pipe than I had to. And the only way to put a voltmeter on this would have been to drill another hole in the pipe. But if I'm going to build a new high voltage generator, which I don't know if it'll happen, but if it does, it could happen by winter, springtime, I don't know. Right now, the relative humidity is so high I can't even run this, or I wouldn't run it. Anyway, so here's what I came up with, is a nice wraparound voltmeter that fits on there pretty perfectly. So this, my friends, is going to be the holy grail of what could possibly be another high voltage generator. This was absolutely 1000% the missing link of what was needed on this one here anyway. Kind of the downfall to these things is once you put them together, that's it. I mean, you're done. There's no taking it apart. I guess I've just got lucky. Nothing has ever blown in it, and it barely leaks any oil at all. Maybe, I don't know, a couple drops a year or something like that. Not sure how I pulled that off. That's the other issue with building these things, is how do you keep all the oil from pouring out the bottom of it with a bunch of wires going up into it? So I wanted to show you a couple things about this voltmeter that I put together here the past couple days and how it's going to attach inside the third generation high voltage generator if that day does get here. Now, for anyone that didn't see my videos on the power supply for this is kind of misleading because you kind of see that there's a piece of SOW cord here. No, this does not plug into the wall. That wouldn't be good if you plugged this into the wall. So yeah, I didn't want you to think that that is AC line powered. The flyback and everything, the oscillator is all underneath the dog bowl. That's where it all lies. The almighty power of the dog bowl. So for anyone that's really not familiar with electronics, you might be thinking to yourself, well, how in the heck do you put a voltmeter on something that's 150 kV or something like that? That would be an understandable thought. It's actually really super simple to do. But like I said, it just involves putting another hole through a piece of PVC. So what we do is we just string a whole bunch of resistors together, high voltage resistors. So these are all going to be 10 megs. There's going to be 8 of them in the string here to form a big, huge voltage divider, all against an 18.96K down here on the bottom. So when I set 16.6 kV there, it's going to set 3 volts here at this point. There is no way to measure the voltage coming out of the top of it. What you have to do is you have to measure the voltage going into the multiplier. Because if you know how much is going into it, you can calibrate your voltmeter off the input to it to what the output voltage would be coming out of the top. So that's exactly what this does. So there really wasn't any rocket science here to just forming a whole string of resistors to make a big voltage divider. Just to divide this voltage down to something pretty manageable. This right here will be the point that breaks through the pipe at some location. There's actually an insane amount of calculator time involved in determining what these resistors need to be. And the reason for that is when you set your current coming down through the resistor string here, which is a function of the voltage up here and the total resistance of all those string resistors. And you come up with what your current is. In the case of this one here, it's like 208 microamps. Well, you got a 50 microamp meter movement here on this meter. And that's where the math fun time comes into play, because you can easily, in a couple strokes of a calculator key, calculate 3 volts here at this point and what resistor you need to put down there to give you that 3 volts. But when you put the 50 microamp meter movement on it, it loads this point down. So your calculations are all null and void. Because if there's 208 microamps coming down through here, pulling 50 microamps off to drive the meter only loads that point down. So it took a couple hours actually of going through values here to see what this voltage had to be in order for this meter to be connected to it and the voltage at this point here be 3 volts. This is a 50 microamp meter movement, so it's 20,000 ohms per volt. For every volt that you set on it, you need 20,000 ohms. So if we want to make 16.6 equal 3 here, then we need a 60K resistor on it. And when this voltage hits 3, this meter will be exactly full scale. So the way the math worked out for this is this point had to be all but 4 volts, about 3.9, in order for when this meter is connected to it, for that voltage to drop to 3 volts. So the voltage up here had to be calculated almost a volt higher than what the voltage was that we needed here. So anyway, when there's 16.6 kV here, which is going to be making 300 kV come out of it, this 50 microamp meter will be full scale right on the mark with 3 volts here at this point. So it's a really simple way to measure a really high voltage just through a string of resistors. Now the voltage rating on these resistors is going to have to be probably about 2 kV or so. 2, 4, 6, 8, 10, 12, 14, 16, about 2 kV. The resistors that I ordered for this are 3 kV, and this will be super accurate. It will be every bit as accurate as what these 10 megs turn out to be. If these 10 megs aren't accurate, this isn't going to be right on the money. That's just how it works. I mean, this value down here and the way that I did things is going to make it extremely accurate here. But if these divider resistors are off, that's going to throw the meter off. I kind of figure it may be off by as much as maybe 10 kV, 15 kV. But when you got 300 kV up there sitting at the top, you know, who really cares about 10 kV? It's just kind of the way I see it, because this high voltage generator here, you have no idea what's coming out of it. It would be a blessing to be within 10 or 15 kV of what's coming out the top. So I thought I'd go one step further and put a DVM connection on here to read the voltage coming out of it with a DVM. It's just kind of redundant, but that's just my methodology in over engineering stuff. That way I can just flip this switch down and be able to read it on a DVM. So there's really not much to it. That's all it is, but it did take some time to cut this all out, because I cut this all with a jigsaw, basically laying down on the ground. So the fact that it even has an even radius to it is kind of astonishing. So this will wrap around that pipe exactly. This radius was actually cut a little bit bigger, because what I've done in the past is I take some really big, huge tie wraps and tack the tie wraps around here, or a combination of nail the tie wraps and hot glue the tie wraps, and then just stick this up against the pipe and draw up the tie wraps. It's a pretty effective way to attach this onto a piece of pipe. There's 220K resistors there for the meter, and then there's 220K resistors right there for the DVM, because the values needed to be 60K. So there'll be 18 stages to the multiplier, so 16.6 kV in, 300 kV out. Kind of funny note, I bought this meter the other day, and when I got it, I looked at it and I was like, wow, this is super cool. Put a resistor on it and checked it on the power supply and everything. I didn't really notice anything about it. And I went ahead and built this for it and mounted the meter, and after a while I looked at the front face of the meter and I said, well, hell, that ain't the right meter. Now, this meter doesn't go to 30, which would be 300 kV. And I thought, oh man, I just left this guy feedback. He's going to think I'm a lunatic. So I sent him a message. I said, sir, I hate to tell you this. I said, you sent me the wrong meter. I had known because I paged through thousands of items and I saw that he had two of these that were almost identical. So what he did is he ended up sending me the wrong one. But I felt really, really badly because here this guy is. He's selling these meters for $5 a piece, which to me is underpriced. But the shipping on them is $16. You know, my first thought was, well, I'll pay for this meter here. But, you know, honestly, I can't afford to pay that kind of shipping cost. And, you know, obviously his method of fixing it really wasn't the same as my method of fixing it, because what he did is he said, okay, I just sent you another meter. And I told him, I said, man, I said, that's really rough. I said, you basically given this stuff away to me. I said, is there any way that I can reimburse you over eBay? And I kind of hate that about eBay, because there's been several times over the years where I needed to make something right with a seller and send them some more money, and there's no way to do that on eBay's platform. I felt so badly for this guy because he dished out 2 meters and two $16 shipping charges. I mean, for pennies. That's exactly why I don't sell on eBay anymore. Poor guy lost out really, really badly. He's supposed to be sending me the new meter, and I probably should have it in a day or two here. So back to what I was saying about possibly building a new one here. So I found some 20 kV diodes. They're not the Veros. I have my fingers crossed. I'm going to need 36 of those things. Now the caps, I found these guys here. And if there's any part of this project that's going to fail, right here is going to be the failure. These are 1500 puff at 21 kV. I need 72 of them. This high voltage generator, oh my God. You know, I was thinking, I thought, you know, if you do build another high voltage generator, you got to make that thing lose some weight. But now, I'm kind of thinking this one here could weigh twice as much as what that one does. It's just not a good thing. I don't think there's any way to make something lose weight when it's got that much ceramic, oil, and PVC to it. That's kind of the bad thing about it. So anyway, enough rambling. Thank you very much for watching my video. You take care and have a great day.